In today's video, we're going to be talking about the product rule for derivatives. This is a strategy that can help us solve problems when we have two functions being multiplied together and we want to find their derivative. The rule is as follows. The derivative of f of x times g of x, in other words, two functions being multiplied by each other, is equal to f prime of x times g of x plus f of x times g prime of x. Now remember, prime is represented by this little apostrophe, and prime is the same thing as the derivative. It's just a shorter version of writing d dx. So let's use this rule to solve some derivatives. It takes a little practice getting used to, but fortunately we have this addition sign, so if you accidentally multiply f of x times g prime of x here instead of f prime of x times g of x, it doesn't really matter because you can flip them and it doesn't change anything. Anyways, let's do the examples now. Example number 1, 3x squared times 7x, and we want to find the derivative of this function. So how might we find the derivative? Well, clearly we have two functions being multiplied by each other. After all, this is the product rule video. So let's first establish what f of x is and what g of x is. And it doesn't really matter too much if you choose one to be f of x and the other to be g of x. As long as one of them is f of x and g of x, it doesn't matter. For me, I'm going to use the first function as f of x, this 3x squared, and our second function, 7x, as g of x, as such. Now we need to find the derivative of each of these functions individually, and we can do that over here in this space. So the derivative of 3x squared, which will apply here, can be found using the power rule, which I made a video on recently. You can check it out over there. So let's do that. The derivative, d dx, of 3x squared, if we use the power rule, we bring this 2 to the front and then subtract 1 from our power. So this is equal to 2 times 3x to the 2 minus 1 power, which is just equal to 6x. So now we know what f prime is. We can write it here. Let's write that here. So our f prime is just 6x, and then multiplying that by g of x, which is just 7x. So the first half of our equation is 6x times 7x. Now we have to add f of x times g prime of x. So let's add f of x, which is 3x squared. And now we need to figure out what g prime of x is. And here we have g of x, so let's find the derivative. Once again, in order to find this derivative, we can just use the power rule. The derivative of 7x, remember there's a little invisible 1 here. We can bring that to the front and then subtract 1. So this is equal to 1 times 7x to the 1 minus 1 power, which is 0. X to the 0th power, anything to the 0th power in fact, is just equal to 1. So our derivative is just 7. So we multiply 3x squared by 7. Now that we have everything, we just need to multiply everything together. 6 times 7 is 42, and x times x is equal to x squared. So the first half is 42x squared. Now we have 7 times 3 is 21, and we just tack on the x squared. So this, we also add 21x squared. And since we have a common variable in x squared, we can just add them together. So 42 plus 21 is equal to 63x squared. And that is the derivative we found using the product rule. Let's do 2 more examples for this video. Next we have the example 4x times x plus 7. And you'll notice that this example is slightly different because in the parentheses we have x plus 7 instead of something like 7x or something similar where we have a coefficient attached to x. We can still apply the product rule to this. Let's do that. Once again, let's establish which one's f of x and which one's g of x. I'm going to use this one at 4x as f of x and x plus 7 as g of x. Kind of like before, first one is f of x, second one is g of x. You don't have to do it like that, but it just makes more sense to me. So first let's find f prime of x, and I'm going to erase that so we have a little more room to work with. So we need to find the derivative, or f prime, of f of x, which is 4x. So we're just finding the derivative of 4x. Once again, we can just use the power rule, so we bring our invisible 1 here to the front, and then subtract 1. So this derivative is equal to 1 times 4x to the 0th power. Once again, x to the 0th is just 1, so this cancels out. So this derivative is just 4. So the first half of our equation is set. F of x, which is just 4, is being multiplied by g of x, which is x plus 7, as so. And now we need to add f of x times g prime of x. So we already know f of x, that's just 4x over here. Add 4x, and then multiply that by g prime of x. So let's find the derivative of x plus 7. Doing that up here, we get d dx of x plus 7. So we can actually split this between the addition sign, meaning we can solve this derivative and this derivative individually and combine them together to get our final derivative. The derivative of x is just 1, and using the constant rule, the derivative of any constant is just 0, so this derivative is just equal to 1. So this is just 4x times 1. Now we just have to distribute and add everything together, so this is now equal to 4 times x is just 4x, 4 times 7 is just 28, and then 4x times 1 is just 4x. So the derivative of 4x times x plus 7 is just equal to, we can add these two together, 8x plus 28. And that's our derivative. Not too bad, right? Well, let's do one more example that's a little bit trickier. Our last example is 3x minus 1 times x to the fourth plus 2. Let's find the derivative of this. And as you can see, we have two different functions being multiplied by each other. So once again, we do need to apply the product rule. So first, let's establish what f of x and g of x are. Once again, we'll just use the first function as f of x. So 3x minus 1, it will be our f of x, and x to the fourth plus 2 will be our g of x. Now let's use our product rule. First, we need to find f prime of x, in other words, the derivative of f of x. So let's find the derivative of 3x minus 1. In my properties of derivatives video, we talked about the sum and difference rule, and we just did that up here actually, and we can apply that here. We can separate these two by the subtraction sign and solve them individually. The derivative of 3x is just equal to 3. We did a very similar example up here using the power rule, and the derivative of any constant such as negative 1 is just 0. So the derivative of f of x is just 3. Writing that down here, we get 3 times g of x, which is just x to the fourth plus 2. And now we just need to add f of x, which is 3x minus 1, times g prime of x. And we're going to solve that down here as well. Our g of x function is x to the fourth plus 2. So d dx of x to the fourth plus 2. Once again, we can split this derivative by the addition sign and solve for each of these derivatives individually. So first of all, the derivative of any constant is just 0, so we don't have to worry about that. Using the power rule, we can take that 4 down to the front and subtract 1. So our derivative of x to the fourth plus 2 is just 4x cubed. So let's plug that in up here. So we're multiplying all that by 4x cubed. Okay, that took a second, but now we can pretty easily just FOIL everything out and solve. So let's do that. We can multiply 3 by everything in the parentheses, and we can multiply 4x cubed by everything in these parentheses. So this now turns into 3x to the fourth plus 6. 3 times 2, of course, just being 6. 3x times 4x cubed. 3 times 4 is just 12. X times x cubed is just x to the fourth. So this is plus 12x to the fourth. And then 4x cubed minus 1 is just negative 4x cubed. So simplifying this down, the derivative of 3x minus 1 times x to the fourth plus 2 is equal to 15x to the fourth. We can add 3x to the fourth and 12x to the fourth, minus 4x cubed. That's the only cubed x we have in here, and then just plus 6 on the end. And that is our derivative. I hope this video helped you out. If you want more details on other rules for derivatives, such as the quotient rule, the chain rule, and the power rule, you can check them out in this playlist, and they may have been linked throughout this video in the info cards. Consider subscribing if you want more calculus help, and I will see you guys in the next lesson.